In order to understand the principles and practices of electrosurgery, it is mandatory to understand the fundamentals and principles of electricity. Let's get started. Before diving into the principles of electricity, let's first understand what electricity is. Electricity is the flow of electric charge, typically carried by electrons, through a conductor. It is a fundamental force of nature that powers our modern world. There are two important principles that govern the behavior of electricity. Understanding these principles is essential in comprehending how electricity works. Let's take a closer look. The first principle states that electricity always seeks the ground. Ground refers to a reference point or a conductive path that serves as a return route for the electric current. This principle helps ensure the safety and stability of electrical systems. The second principle of electricity is that it always seeks the path of least resistance. Electric current naturally flows through the easiest route available, which means it prefers pathways with lower impedance or obstacles. To better understand electricity, let's familiarize ourselves with some important terms related to circuits: current, resistance, impedance, voltage, power. A circuit refers to a closed pathway that allows the uninterrupted flow of electrons. It comprises various components like conductors, resistors, switches, and power sources. Current represents the flow of electrons through a conductor over a period of time. It is measured in units called amperes, A, and is denoted by the symbol I. Electrical resistance is like a speed bump for electric current. When you have a flow of electrons, current, through a wire or a device, the resistance is like a barrier that makes it harder for the electrons to move freely. It's like how traffic slows down when there's a speed bump on the road. The higher the resistance, the more the electrons get slowed down, less current, and the lower the resistance, the easier the electrons can flow through, more current. Electrical resistance is measured in ohms. Electrical impedance is like a combination of resistance and another factor called reactance, and it describes how much a material or device resists the flow of alternating current, AC. It's like the total opposition electricity faces in AC circuits, measured in ohms, omega. Voltage is the force or electromotive potential that pushes the electric current through the impedance. It is measured in volts, V, and is denoted by the symbol V. Power is the effect of voltage pushing the current through the impedance. It represents the rate at which work is done or energy is transferred. Power is measured in watts, W. Ohm's law establishes a relationship between voltage and current through a linear resistance. According to Ohm's law, the current flowing through a conductor is directly proportional to the voltage applied across it and inversely proportional to the resistance it encounters. Here, the voltage analogous to water pressure, the current is the amount of water flowing through the pipe, and the resistance is the size of the pipe. More water will flow through the pipe. When more pressure is applied and the bigger the pipe, lower the resistance. Remember, electricity is a fascinating and powerful force that shapes the world around us. In the next video we will be understanding the application of electricity in electrosurgery.